I guess we can start it with the webinar. So first of all, good morning and welcome everyone to this second community webinar we're organizing with tExtended, following the first one that we had in October last year. My name is Claudia Esposito. I work on the communication side of tExtended, and today I will be the host of the webinar. Over the next 2 hours, we're going to hear 3 presentations from 3 different tExtended partners. We will have first, Mr. Nacho Montesinos Beltran from IMPlus, who will give an introduction on IMPlus and their role in tExtended. Then we will have Mr. Edwin Maes from Syntex Bell, who will talk about the report that we worked on and published with work in tExtended about redesigning value chains. And then we will have an introduction by Mr. Jean-Luc Deric from UTEX Bell, who will talk to us about the work that they have done to develop their circular fabrics called Dr. Green. The last presentation then today is going to be from outside the project, will be done by Ms. Emma Enebok from RISE, and it will be about the work and results obtained in SISUTAC, another Horizon EU-funded project. If you have any questions that you want to ask to the speakers during the presentation, you can drop them in the chat so that at the end we're going to have a Q&A session and we will read them out to the panelists. Unfortunately, not all of the speakers can stay until the end of the meeting today, but we will still, so probably not sure that all questions will be answered today, but we will still collect them and we will still send them by email so that we can give you an answer after. As well, if you have any questions or any kind of clarification that you want after the meeting, you can always contact me. You find my email here. You'll find it also in all the Zoom invitation, and you'll find it in the follow-up email, so plenty of chances to remember it. And we will come back to you with answers. Last technical arrangement is that we are recording this webinar. As we will share it then on the website. Your names and faces will not show, and then we will also edit out the Q&A session, so none of your personal data will appear today. So thank you for the cooperation and the attention. I can stop sharing this one and leave the microphone to our project coordinator, Dr. Pirja Ekila from VTT, that will guide us through a short introduction of the project and its recent developments.
Thank you, Claudia, and welcome also from my behalf. I will have to look how to share it. Yes, I think we are there. Okay, so in a previous webinar, I gave a little bit longer introduction of the project, but since there are new members joining into our a group and this network, I think it's better to have a short kind of reminder for those who have been involved with us longer, and for newcomers a short introduction of the project in general. Yes, so the specific needs who triggered the project preparation is hopefully not a new thing to our audience. I expect we have a lot of textile experts involved. So basically, the current system is not sustainable. There are production and use habits are kind of more about amount than quality of materials, and of course we also generate a lot of textile waste. In order to move more circular system, there are a lot of technological, non-technological challenges we need to solve before we go. Of course, also regulatory framework has been changing, and in the beginning of this year, all EU member states should have separate collection of textile waste operational and running, but when this is collected, it needs to be, of course, sorted and recycled. Currently, the sorting is mostly manual. There is a need for technologies, identification, for also practices for collection and automated sorting systems. And also there are a lot of things that we need to build for recycling, even though there are also, of course, some recycling actors already there, but there are so many different things we need to decide. Blended textiles is one example. Current systems are mostly focused on certain type of waste or all lower value applications, and we need to get this recycled raw material, secondary raw material for textile industry, since our currently used kind of virgin materials are not sustainable either. So in order to improve sustainability, also this circularity is a must. In our case, we also looked on digital and data sharing aspects. So in order to really kind of fully support this kind of textile flows and circular system, trying to understand, optimize it, and make it more efficient, we need data sharing, and we also want to motivate kind of all stakeholders of the textile ecosystem for this, using data and sharing it more openly. We have certain concepts kind of launched for our project, a little bit abstract. We want to our overall objective is to build this kind of master plan blueprint, how this system can be circular system can be more sustainable, and how the products and materials are cycling there, and we can then produce raw materials from these sources and also reduce amount of waste. And based on the background of this blueprint is conceptual framework, so kind of theoretical knowledge-based system where we want to use for optimization of different kind of textile flows. And we aim in that we keep the value and increase the value whenever possible, and doing it in safe and sustainable way. So we are looking that we are not causing too much environmental impacts, but also try to do it economically beneficial way. When we have built our conceptual framework and blueprint based on that, we are going to implement the real scale demonstrator, which was one request in this call. And in there we are demonstrating our solutions and looking how could we potentially, with our solutions and other solutions which are developing outside of our consortium, to reduce textile waste by quite a lot, by increasing reduction of waste and then increasing product reuse and material recycling. And in order to get this all happen, we have also other activities in the project. So we are developing systemic understanding and basis for this kind of sustainable and safe textile ecosystem. We are building knowledge and digital solutions. We are trying to make sure that textiles can be collected, sorted, and also reused efficiently. And then we are developing waste valorization and recycling technologies for aiming for higher value application whenever possible. This is an illustration of the work packages, and this, I don't know if you can see my mouse, but we are having very practical and process development oriented work packages, work package 2 and 3. So what is needed for textile recovery and waste valorization, and then for textile recycling technologies. In work package 1 and 4, we are more building knowledge and theoretical background. And in work package 5, we then focus on the demonstration and its replication potential. And also, like all EU projects, we are going to evaluate sustainability and circularity of our technologies, and especially focusing on these evaluations on the demonstration activity. So we have this activities. We are more on theoretical experimental and then also engagement. So when we study our replication potential, we are looking what is happening in different regions. Also, what was expected from the project by Cortex, this social innovation spin-off. So something how we engage with citizens in order to enhance circularity. This is quickly our partner distribution, 20 partners from different countries. You can look on our project website and so a short introduction of each. And there are also some numbers. So our project is 4-year project. We have just passed our midpoint and it's quite large, over 15 million budget with the EU contribution around 12 million. And this is an overview of the milestones of the project. And we are currently closing our milestone 4. We are ready to kick off our demonstration activities. So we have been kind of building the background and started development work. Now we are preparing for demonstrator and we will start it within a couple of months. I think here are still our communication channels and also how to join this group. And I think that's enough from my side so that we have enough time for all our presenters, not just hearing the project intro. Thank you.
Oops. Okay, perfect. Thank you, Pirjo, for the introduction. I guess we can then start with the project presentation. The first one on the agenda is Nacho Montesinos Beltran from IMPLUS with an introduction about IMPLUS and their work. So, okay.
Hello, can I, one moment.
I think you should be able now. Yeah.
Okay, well, welcome everyone. My name is Nacho and I work as a technician here in 9+. And in this webinar, I will talk about IMPLUS and how is our role and what are we doing in tExtended. So, sorry. Okay. So what is IMPLUS? Well, IMPLUS is a technological center with more than 30 years experience in the plastic sector, and I don't know what. One moment. A technological center located here in Valencia with experience in the plastic sector, and what we do. Well, I have some problems. Sorry. No. What we do, well, we add value to the companies to generate wealth and create employment in terms of new technologies, develop new processes, and this provide more value also to the society to improve quality of life and ensure environmental sustainability. Basically, we make projects in national level, European level, with different entities, different companies to make projects to improve all of these parts in the sector. Because as we know, the plastics are in all the markets, obviously in the textile market also. And our focus is not only in the chemical recycling department, but it's not only in terms of recycling, because we have different departments that they cover the entire plastic value chain, starting from the synthesis of the monomers and the synthesis of the polymers to obtain our raw materials. We have a lot of different equipments to make also the compound with the polymer, with additives, to make some final product, always in terms of pilot scale, and from lab scale until the pilot scale with TRLs about 7 and 8 in some cases, to manufacture it and obtain a final product. Obviously, The next part of the life of these materials is the recovery of this plastic. We have different ways. We have the chemical recycling, the mechanical recycling, the biochemical recycling, also the biodegradation, and different ways to add value to all of this kind of waste. So this is more or less what we do in terms of technology that we use, and I will start talking a little bit about the different recycling technologies to make sure that I will talk in the next slides with more knowledge. So, well, basically, when we have a waste, we have the typical way to recycle this waste, and is the mechanical recycling. This is the more established way to recycle, with washing, grinding, sorting, and finally we melt and obtain a pellet or something to another time make a plastic compound. In tExtended, for example, in Plus, we work in the sorting, also in another kind of technologies, but one of the main is in the sorting to try to obtain a flow with more homogeneous materials to have a better recycling step in the after this. But also we have different ways to recycle, as the dissolution reprecipitation technique. I will talk more in the slide because this technology is used also in tExtended. And basically this technology is to put some solvent in the waste and try to dissolve only the polymers or only the substances that we want selectively. Using some solvent with some temperature, with some pressure, we can purify. We can also eliminate an ink to make with no color. We can separate different flows in the polymer that we want to recover. And obviously, once we have this polymer, we can, with mechanical recycling, for example, obtain a pellet to make another time a plastic compound. But sometimes this is not possible, because when it's not a thermoplastic, we can't dissolve some polymers, and in that case we have the depolymerization, and we also have some work in this term in tExtended with the solvolysis of polyurethanes. I will talk a little bit more later, but when we make this depolymerization with the solvolysis, we break the polymer into these first regions to synthesize another time the polymer. With this kind of recyclings, we can obtain another time reagent with the same purity and with the same characteristics as the virgin monomer to make another time a virgin polymer. This is a little bit a sum up of the different technologies in the chemical and mechanical recycling. Also, we have different technologies with pyrolysis and gasification that breaks a lot more the polymer only with temperature. But as in tExtended is not used this kind of technologies, I don't want to talk a lot more. If you want to know more, you can talk with me with the email. But basically, I will talk until now in the dissolution reprecipitation, the depolymerization with solvolysis, about the sorting of the different materials. Well, this is that I said of the dissolution selectively of the different polymers. This kind of technology is used to dissolve a polymer or an adhesive. In the multi-layer waste is very useful to can separate different polymers, different films, because we dissolve only the polymer that is binding the different layers. Also, we can extract different additives of interest or eliminate some impurities. This is we could see that as a pre-treatment of the waste to have with a more purified way. And this is also a sum up, okay, with the thermal cracking that I say that is not used in tExtended, and the solvolysis that in tExtended is used for the polyurethane material. Okay, and what are doing here in tExtended? From one side is all the sorting. We are developing some systems to sort the different textile materials to try to separate and have a flow with some homogeneous to have a better quality of the recycling step. In that case, we have a near infrared recognition is very cool to see, because with the infrared we can separate the different polymers or different materials only because with this infrared this machine can separate in different ways to have as I said a more homogeneous mixture to try to recover the best recycling materials. Also, we have make with the turboelectric separation. In that case, is for metallic and ferrous materials. We can separate these ferrous materials and the rest of the materials, and is very useful also because with all of this mixture of different ferrous material is very difficult in the later steps try to have a good material to recover with an upcycling and not to make a downcycling of this waste. And the last one is the turboelectric separation. This is by density because the different materials have obviously different densities, and with a zigzag is called of the with an air we can separate the materials with more density and the materials with less density separate, and obviously another time have a more homogeneous flow to make the recycling in the next step. We can make in the next step a mechanical or chemical recycling, but with this sorting we can have a best flow in terms of quality. Sorry, this is the elucidation sorting. And well, I will talk now about the physicochemical dissolution. That is, as I say, to dissolve selectively one of the polymers or one of the additives. In that case, we have a multi-layer material composed with PVC, polyurethane, and PET, and we want to dissolve only the PVC. The PVC is the molecule that we have in the slide. And with using one solvent, with one temperature and different parameters, we can dissolve only the PVC with all the polyurethane and the PET remaining undissolved in the mixture. And after a filtration, we recover from one side this mixture of polyurethane and PET, and from the other side, we recover and we can reprecipitate this PVC. And this is in the lab scale, but obviously in higher productions, we can, in the next step with this PVC, make some pellets or make some material to have a PVC with recycled PVC to make another time another product. With another fraction of the polyurethane and polyester, well, we can think in another ways to recycle, for example, with the solvolysis of the polyurethane, of the solvolysis or of the polyester, depending on the focus that we want to have. But this kind of technology of the dissolution is very useful. This slide, because it's like a sum up of the different separations that we obtain. And finally, we have a PVC with a high purity, starting from a multi-layer material that is very difficult to recycle with the typical technologies of mechanical recycling and this. And the last one technology is the polyurethane solvolysis. Basically, we have a foam. Okay, this is the foam that we have. This is a polyurethane foam. And this is the molecule of the polyurethane, and what we want to obtain is to break this molecule, this chain, to obtain finally a polyol. A polyol is one of the reagents of the polyurethane. So using some reagents, we break this polymer to obtain the polyol. Okay, this is called glycolysis, and with the polyurethane, we can make the reaction, make the solvolysis to break this polymer to finally obtain a polyol. Okay, with this polyol, it looks like this. You can later make some steps of purification or not, depending of the requirements. But as less steps of purification, more easy to go to the industrial scale. So we want to try to make with the less purification steps possible as possible. And basically, after this process of solvolysis, with this polyol, we can make another polyurethane, because with this polyol, we can make a synthesis with the isocyanate to recover a polyurethane with higher content of polyol residue. Depending of the formulations, you can put a more higher or less percentage of this polyol. This is one of the optimization steps. Now in tExtended, we are in the phase of the optimization to try to recover as best as possible this polyol and try to do it with the less amount of reagents as possible. So now we are in this step, and once we have the best formulation, we will scale up to reactors of 50 or 100 liters, depending of the conditions. And I forgot, but with the PVC removal is similar. We are making some steps of optimizations and steps to try to know the studies of LCA or SSDB to try to have not only done as a technical part the best way, but also in terms of more green, more safer to try to go to the industrial scale. So this is all, more or less. I hope you enjoyed the presentation. If you want to tell me something, this is my email. And I will stay until 11:15 because I have another meeting. So if I don't, I am not in the questions round, you can send it by email or something. Thank you so much.
Thank you, Nacho, for the presentation. Really interesting to know what IMPLUS is doing and surely involved in many different sides of the project. So for sure, in the next 2 years of the project, we will hear more about your work in it. So thank you for your time. And we will collect the questions in case if you can't make it for the Q&A section. And we can move forward with Edwin Miles from Centex Bell with the presentation about redesigning value chains. So up to you.
And my mic here. You can see me as well now and hear me. Here's an overview of what I will be presenting, short introduction, then the current textile ecosystem, turning towards circularity, the future circular ecosystemic business model, a vision of this future ecosystem, and actions to be taken by the stakeholder. Within the work package 1 in this tExtended project, we made a paper on how a future circular ecosystem could look like, and I added the link to the slides. I believe afterwards the slides will be shared so that you can have a look at the paper, because in 15 minutes we can't elaborate on all of it, so please have a look. This is me. I'm the consultant clothing textiles at Centex Bell, which is a textiles and plastic knowledge center and research institute. We do also a lot of testing. And basically I have both a commercial, a business, and technical and legislative background. like I'm representing Belgium within DG Grow textile labeling, but also I'm involved in a lot of standardization, like I'm the convener of working group 39 within the textile TC that deals with circular economy, and I'm participating in research projects like the tExtended project for Centex Bell. This is an overview of the current textile ecosystem, where use and reuse textiles is mostly used for a short time, certainly when it comes to clothing, fashion. But you see that this practice also is implemented in other bits of the textile industry. You can think of Zara Home, for instance, where you have interior textiles that is used for a shorter lifespan than it was 20 years ago. So second-hand is increasing, but it's still marginal compared to the virgin fashion market. And then other strategies like repair, refurbish, and remanufactured are even less implemented. So when it comes to recycling, everybody knows that there's very little recycled into new textiles. Most is incinerated, and separate collection and recycling is increasing, developing, but there are still a lot of gaps. So when everybody talks about the circular economy, you end up often with the R strategies, and they are coming from other industries, or I implement a circular economy in other industries, like the electronics industry, which has already eco-design legislation for a long time. And you then see that translating these practices towards textiles is not always as easy. So we try to have a schematic overview where the last strategy is really to be avoided. This is by making sure that whatever you do, you can recycle it. But the best is still to have it reused, to have it repaired and refurbished. And this can be done for the same consumer, but also for other consumers. And we put repair and refurbish on the same level, because there's a very thin line when we look at textiles. For instance, reapplying dye stuff by garment dyeing, which is not done at the moment, but it could be done. Would you consider this repair or refurbish? So therefore, we see that repair and refurbish, that you would basically put them a little bit in the same line. Whereas for remanufacture and repurpose, where you would use parts of a textile product and make a new textile product from it, or implement it in a new textile product, the difference between those two is open and closed loop, basically. So also there we put them together. So, and then you have the other R strategies that are more linked to the design strategy. I said everything, whatever you do, you need to be able to recycle it, because otherwise you will end up with recovery. Also there you will see that, so you have on the left bit what was before. So then after sorting, you might decide, okay, or after applying another R strategy, you might decide, okay, we need to recycle this bit because we can't use it any further. Then still you need a preparation for every recycling step. So this could be done together, where you have, for instance, a certain output that are mechanically recycled fibers, but then the fluffy material of fibers that is not be usable for spinning anymore go to another recycling technology, where you have this cascade system. And of course, from every step, probably you will have some waste that will go to recovery. But that is to be kept at the lowest. There's a lot of legislation coming up, especially from Europe, where the Circular Action Plan led to an amendment, the EU Waste Directive, which is tackling textile to a large extent. There's a circular economy action plan that led to a sustainable and circular strategy for textiles, and that influenced a lot of bit of legislation like the EU Waste Directive, Green Claims Directive, textile labeling rules, eco-design for sustainable product is out there, and now an investigation is conducted on how the delegated act for textiles should look like, that is developed within this framework legislation, eco-design, and there are more upcoming initiatives that will support the circular economy. So a future circular ecosystemic business model, we see that there are, so the consortium noticed that there are a lot of missing actors. So one of the important ones is an orchestrator that puts up the whole value chain, that organizes it, then processes of underutilized resources, processes of waste are lacking, local actors. So we used to have, for instance, in Belgium, every type of textile production, but that is a long time ago. A lot of disappeared to the Far East. So collectors and sorters are missing, technology providers, the know-how, and the machinery is not always there, needs to be developed, and then important data providers. So to operate, so for instance, to develop and operate a supply chain mapping tool, providers of data for future processing are missing. There are also a lot of barriers, a limited unsuitable market structure, so like the missing actors, difficulties in establishing cross-value chain interactions, not always the same language is spoken, or you don't have a common view, dispersed cross-value chain requirements, like I implement certain dye stuff which make that it can't be recycled, for instance, or legislative needs that need to be met that are impossible. And then there's also the lack of in-house competence, not knowing that we need certain partners in order to get there. So we identified a lot of motivators, drivers, and enablers that can help the circular economy or the transition towards the circular economy, like B2B customer requirements that are asking for circularity, replacing the virgin materials, or organizing as a textile industry as a whole certain material flows from their production waste, for instance, in order to make it interesting to put up certain recycling systems. Being a forerunner could give you a competitive advantage. The cost reduction is implemented within the textile industry to a large extent. So that is basically something where the textile industry is very good in. Corporate responsibility can have a push because the consumer has an opinion upon this topic, and it can influence sales. Legislation and regulation is the strongest motivator, but you need market surveillance. So you need to control that this legislation is checked. New business opportunities are there, and also from the social responsibility, social employment, there could be a push. So what is the pathway then towards this future circular textile ecosystem? We questioned all the commercial partners within the consortium, and they expect that in the coming 5 to 10 years, we will have accomplished this transition, but we need a mindset, a change in the mindset, and a change in the role and cooperation between stakeholders, change in recycling, production, manufacturing, and design of textiles. Legislative change is for sure on the road, and change related to the environmental, sustainable, and circular consumption of textiles. So the consumer has a very important role. And what we need within this textile ecosystem is sustainable production and products, so that you produce at a low CO2 emission, that you source bio-based, recycled, that you have durable products on the market with a long lifetime. That tackles use and reuse. You want to use textiles not for a short period, but for a long period. Make sure that it is reused. If the owner doesn't use it themselves again, it's repaired, that bits can be reused. And then at the end of life, everything needs to be recycled in order to valorize the materials that have been used to make a product. Then you would come up to this vision that we developed on the future ecosystem, where you prioritize like in high quality, a long use time, and then reduction of production waste. Those are very important, and you go then over collecting, sorting into high valorization of your waste, using data classification systems in order to then go to, as much as possible, reuse via products. If that is not possible, reuse the bits of these products, reuse the textiles and other bits, and then only if that is not possible anymore, to go into these recycling, into recycling the materials, where also you could have a cascading system. So there are a lot of actions that need to be taken by the stakeholder, the legislator, and they are doing this, preventing promoting of overconsumption, one-time use of products could perhaps be tackled. The EPR schemes could make sure that single-use items are more expensive, prohibit practices like promotional goodies that doesn't satisfy a certain need. Everybody knows things they received, and then 10 years later, you find them in a drawer, not being used whatsoever, and you throw them away. Increased market surveillance. The European Commission is very aware of that, and this on the agenda. Supporting facilitators. So all these new technologies that are emerging, that or new practices that could help turn businesses circular, they are struggling because often they are more expensive. So they need support, for instance, via the EPR schemes. The professional user only buy what is needed. Often too much is bought because they give packages. No, it should be neat, steered, and the internal user should be made aware. Total cost of ownership should be the basis of buying goods, not the price, and even the true cost would be a better practice. They need to implement end-of-life solutions when they are buying. So think already, when we don't need it anymore, what are we going to do with it? The retailers need to rethink their value capturing, not only just sales, but try to capture value with other things like reuse and repair. Designers need to implement design principles like disassembly or ease for disassembly or repair, recycle materials. Consumer need to consume conscious and, very important, dispose the textiles in an orderly fashion and take a second life into mind. Producers need certainly pay attention to quality, should only put qualitative products onto the market, and then R&D centers need to support all the stakeholders within the transition. So this was an overview of what you all can find in this document. If you have questions, unfortunately I need to leave, I need to give another presentation on the digital product passport, but please send me an email if you have questions and have a look at our document.
Thank you, Edwin, for the presentation. A lot of information about redesign value chains and a lot more that can be said. But as you linked in the first slides, we have the whole report available on the website, and we'll link it in the follow-up email. So if you're interested in knowing more about the research that we've done and the report that we have written, the whole report is available and downloadable from our website. So thank you again. And we can slide to the third presentation, which is this time Jean-Luc Derrick from UTXBEL that will talk to us about their work on the development of Dr. Green and their circular fabrics. So microphone is yours.
Yes, good morning all. My name is Jean-Luc Derrick. I'm a Director of Sustainable Development at UTXBEL. And yes, I'm already 36 years at UTXBEL. And well, the last years focusing on the sustainable development. Are you showing the presentation, Claudia, or should I do it?
Oops. Okay, sorry, we closed. As you prefer, I can share it for you if you prefer.
Yes, if you.
Okay, just a second, I can share it. This one, yeah. Okay, should see it now. Just a second.
Okay.
It should be full screen in a second. Okay, yeah.
Yes, okay. If you can go to the next slide, So first of all, I will present you in brief the UTXBEL company. So it's a Belgian textile family-owned business. And we are still quite unique in Europe as we are still integrated from fiber to fabric. That means we have spinning mills, weaving mill, two weaving mills, and dyeing and finishing mills. We give work to 900 employees, of which 700 in Belgium, and we produce yarns and flat fabrics mainly for public tenders. It's about half of the volume. And 40% for protection. So that this means for civil applications, a little bit less than 10% in sportswear, mainly based on certified cottons, and then a few percent in technical fabrics. That means fabrics that don't end up in garments. When developing yarns and fabrics, it's important if you want to go sustainable to combine the issues that you see. First of all, you need to be sure that the fabric that you create that ends up in a garment should be comfortable to wear. Otherwise it won't be used. Should be aesthetic combination of colors and so on. Should be traceable. With the DPP that is coming, it is very important. Performance is, of course, important, not only in the new state, but also after several washes and during the whole lifetime of the garment. Then it should offer protection. You have several European standards concerning flame retardancy, high visibility, anti-staticity, protection against chemicals, and so on. And finally, it should be durable. Your article should at least last for 50 washes or even more than 100 washes if you go to garments that are rented by industrial laundries. So this gives you sustainable products. So next slide, please. So this is location of the different factories. So the main activity is in Ronser, just on the language border in Belgium, where we have a weaving mill and a ring spinning mill, and also the dyeing and finishing facility. So to give you an idea of the capacity, we produce about 50,000 meters of fabric a day. That means about 12 million meters per year. Then fed by open-end spinning mill, which is 10 kilometers from Ronse. There we produce about 3,000 tons of yarns. And in the ring spinning mill, combined with the ring spinning mill in Morocco, we produce about 1,000 tons of yarns, mainly based on special fibers. Then in Moucron, we have a worsted spinning mill, which also produces about 1,000 tons a year, mainly focusing on blends with aramid fibers. We work with the French aramid Kermel, combined with Lenzing FR and other special fibers, so to make mainly flame retardant blends, and those are woven in the Tissage de Bézieux, which is in France, just across the border. And both weaving mills cover about 70% of the input of the dyeing mill, and the other 30% come from commission weavers. Next slide, please. So here you have an overview of the products in which our yarns and fabrics, and so image wear, industrial protection, and camouflage. Next, please. So now we come to the Retex project. This is a project we started in 2017, and I describe in this presentation what happened and to what family it led. Next, please. Yes. So the start of the Retex project was an Interreg project between Flanders, Wallonia, and the north of France. And coordination was done by tExtended. And the purpose of the project was to map different textile flows in the region and looking for solution for reuse of or reworking of used textiles. There were several projects that were started, and one of the projects was to see what could be done with end-of-life hospital garments. Next slide. So with the help of tExtended, well, a small project group was made with tExtended as processing company for spinning, weaving, dyeing, and finishing. And then we had Van Moer, which is a garment maker located in Belgium and in Holland. And they have, of course, contacts with industrial launderers. And the industrial launderers were confronted with a huge volume of polyester, cotton, end-of-life garments for which they looked for a solution. Otherwise, these garments need to be burned. Then with the help of a social workplace, Arcor, which is in Ronse, the collected garments were dismantled, so all hard parts and colored parts were removed. The material was then transferred to a shredder, which made shredded polyester cotton fibers, which were reprocessed to recreate fabric to make garments again at Van Moer. Next slide, please. So the objective was to produce a fabric for workwear in the world of polyester cotton or cotton polyester. So we didn't bother to split the cellulosic fibers from the synthetic fiber. As there was a huge volume of white garments available, we started with that. The purpose was to get to a maximum circular content into the new yarns and fabrics with acceptable mechanical characteristics, an acceptable visual aspect, and important, it should be industrially reproducible, so spinning in large quantities, weaving and dyeing and finishing on industrial machines. And of course, when creating the new fabric, this new fabric should last at least 100 washing cycles, which was mandatory for the industrial owners who rent the garments. Next slide, please. So here we have a few pictures of the incoming garments. So in the trousers, you see they are white, but there was elastic material present, so this had to be removed. And in the vest, you see some colored accents and some hard parts. These had also needed to be removed. So we did that manually. We talk about the period 2018 19, where automatic systems were not existing at that moment. Next slide, please. So at the left, you see the shredded material, and at the right, you see even with manual removal of hard parts, we found one or two hard parts into the bale of the material. And that is very dangerous. So this one was detected at the input of the carding machine, which is equipped with magnets, so that such things can be stopped before entering the machines, because this is very, very dangerous. It gives risk to fire and risk to destroying your carding machine. Next slide, please. So this is the fiber material at the left, coming from the shredder, which is then blended with part of virgin fibers and part of industrial waste, which is necessary to enable a good processing during the carding. Next, please. So here you see what is coming out of the card. We started from garments that have been washed more than or bleached more than 100 times. The cotton in that material is almost dead, so every mechanical action on the cotton fibers reduces them to dust. And this is on the left side, the dust you see in our filters. Dust can, if it is mainly cellulosic, can be used as input for chemical recycling of cellulosic material. You also see at the right side on the flats of the card all the short fibers that are kept out of the sliver material, which you see right underneath. The next slide, please. Yeah. If you hear a siren, it's a testing at our spinning mill. Excuses for that. It will take 5 minutes. Here you have a blend of the material with virgin cotton. We used biological cotton for 1/3 of the blend, and then the blended cans are fed to the spinning machines. So the spinning process is open-end. Yes, you can give next slide. So here you have the yarns that we have produced. So for the Dr. Green family, it's a majority of polyester in a 30 metric, in which all the cotton that has disappeared has been replaced by virgin organic cotton. And then on the right, we made a blend with the majority of cotton for workwear applications. In both cases, we obtain an RKM of 12, 13, or 11, which is a little bit more than 100% cotton, and which is enough to process industrially during weaving. Next. So this is the mass balance, starting from garments. So you lose 15% of your material during removal of hard parts. You lose 10% during shredding. You lose 20% during carding, and 55% remain as good material to be reprocessed in the textile chain. Next, please. So this is the weaving process. So the weaving preparation, the warping, the sizing, and the weaving. Next, please. So here you have the Dr. Green fabric, which has been used to remake hospital garments. So it's a twill of 210 grams polyester cotton, 67 or 6535, in which you have almost 2/3 of recycled material, of which part is from our PET fibers and part is industrial waste, and then combined with the organic cotton virgin fibers. So this is a white fabric. Next. And here you have the little brother with the majority of cotton. So all small colored fibers that could be shredded fibers are camouflaged by the gray dyeing. Next. So what are the challenges that we faced in that project, and what do we need to take into account when we start new projects? The first thing is that you need to have in mind a suitable end application. It makes no sense to make yarns to put it on stock, or to make fabrics to put it on stock. You need an end use in workwear or hospital wear or something else, or even in knitwear. For instance, socks or underwear. So the end customer should be aware of realistic expectations. It doesn't make sense to start from a shirt and to copy that shirt with recycled fibers. That doesn't work. So as a producer, you need to know exactly what the end user is expecting. Yes, the alarm has ended. Sorry for that. So with the collection, second test, thank you. The collection of suitable materials is very important. So materials should be homogeneous, should be washed. All soiled material has to be removed, should be homogeneous in structure, but also in composition and color. And then if you want to process it industrially, you need a batch of at least 5 to 10 tons. With that, you can start on your industrial machines, even during shredding. Well, 10 tons is a minimum. So you need to consider the overall advantage of such a circular project compared to a standard virgin material. The advantage is also that you can remain with local production. You have your material in the neighborhood, let's say in a neighborhood of 50 to 100 kilometers. You have your source material, you process it in the neighborhood, and then you can spin it, weave it also close to your end customer. Of course, the overall price, you should be aware that this must not be too high compared to virgin. I think the garments proposed in the Dr. Green range are about 10 to 15% more expensive than the virgin one, but the lifetime is about the same. So I think bearing that in mind, it should be possible to put such products on the market. Next slide, please. So meanwhile, Dr. Green has given birth to a lot of other family members, and we launched them under the Reficor label. That means that if a potential customer has some material, some homogeneous material with enough quantity, we can look for a project, and of course, that end customer needs to take back part of this material into a new product. So here you have an example based on jeans material where jeans have been shredded to, well, it's cotton material, it's dyed cotton material. This has been processed. So we made a colored yarn. So with the cotton coming from old jeans, you have already a colored yarn. We added a little bit of black polyester to have a mechanical support, and then you have the colored warp yarn. And in the weft, we use recycled cotton with some white recycled polyester to give your white weft, and you get a jeans fabric without any supplementary dyes. Next, please. Here you have other examples in other applications beside garments. So for instance, these are yarns made of recycled polyester and recycled cotton used in carpets. So these are washable carpets used in public places like stores and in the pubs and restaurants and so on. So this is something that is industrially available. Another possibility, if you want to increase the percent of recycled cotton, one of the issues of recycled cotton is that the fiber length is pretty short, but some applications need or don't want to have polyester in it. So we stick to the cotton, and then the other 20% is virgin cotton. And for instance, for upholstery applications, this is feasible because upholstery applications are less washed, so there are less mechanical demands for such articles. Next, please. So this is within the tExtended project, a product we make, and we are making. It's also a jeans fabric, but here we started from post-consumer polyester cotton black workwear, and the fibers were shredded by Rester, which is also partner into the tExtended project. So at the right side you have the jeans fabric undyed, and you can see, well, the small black defects are coming from short fibers within the shredded material. And on the left side you have the same fabric, but in which we dyed the cotton part, and so the small defects are less visible. So for the moment, these fabrics are in washing testing to see what is the lifetime of that fabric. Internally, we made already trials to up to 50 washes, which is acceptable for workwear applications. Well, this is the presentation how the Dr. Green family started at UTexBel already 7-8 years ago, and has given birth to a lot of projects which are industrially available. Thank you.
Thank you, Jean-Luc, for all the information, and interesting to see the end products of all your work on recycling processes, and also to hear about the challenges about applying the circular business model from someone who's been working on it for some time. So thank you again for all the information on it. And I see there are some more questions coming, so for the next slide. But then with this presentation, we can close the side of the presentation from the tExtended partners, and we can go to the last presentation, which is presented by Emma Hennebock from RISE, who has worked on another EU-funded project, SISUTAC, and who will talk to us about the project and the results. So up to yours on the microphone.
Hello, nice to meet you all. I will just share my presentation. Okay. All good?
Yeah.
Yeah, okay, thank you so much. Okay, so my name is Emma. I'm a project manager working at RISE, the Swedish Research Institute, and I've been a work package leader for one of the parts in the SISUTAC project. So I will talk about our report and some results in this report. And it will be about how you can improve your future thinking skills and understanding of the current textile waste flows. Okay, so this is the delivery and the report that we did roughly a year ago. It is called the Circular Transition. Sorry, just need to move that. The Circular Transition Scenarios and Software for Post-Consumer Textile Waste Channeling. And you can find it also on the SISUTAC webpage, the full report. The work that was carried out was a material flow and infrastructure gap analysis. And also we made a tool to support guidelines and roughly a set of rules on how you can channel post-consumer waste more efficiently. I will talk about that, and some future scenarios. So I will talk about these two parts today, that you also find in depth in the report. So understanding the textile value chain in the EU, I mean, we are facing new policy, technologies evolving, and we have many geopolitical aspects that are affecting how we can be competitive and build capacity in Europe. So I will touch the insights I will give from the reports today will touch upon these two questions. What are the definition, or what are the minimum requirements, the need of data that we need to have for recycling and scaling recycling of post-consumer waste? But also, how will EU's textile strategy and the geopolitical factors have an impact on how the European textile industry can build capacity for the future? Okay. So I will start with talking about the tool that we made in SISUTAC. So what we did in SISUTAC together with our partners, that we identified all the relevant data for automated sorting more efficiently of post-consumer waste. And we also went further, and we built a tool with a set of rules on how you can more efficiently, based on data, sort for reuse, repair, and recycling. And on the web page, you can find this tool on the SISUTAC web page. And it is a tool where you can see all the relevant data points that we identified. And you can make a test, and you can see here when we're playing it, this example, that you can then select. You can pretend that you have a garment, or you're gonna produce a garment, and you can then play around with the different data points and learn by doing in this open access tool, and then you get the result. And you can see then based on how you tested it, if your garment should be channeled to reuse, repair, or recycling. And you can also find the Excel sheet where we have all the underlying data if you are interested in all the details. There's also possibilities to click and test in the Excel sheet. So this is the tool then that give you some learnings, and it creates a base, you could say, for what is a definition of recyclability when it comes to waste. Okay, so what were the data points that we identified? Well, our partners represent the whole the whole value chain for the textile industry. So they, together with other stakeholders, gave us input. And in total, we identified 23 data points that will have an impact for decision making for an efficient channeling of waste to reuse, repair, or recycle. So based on this, we find it's important for the upcoming digital product passport to, well, it might be even important for future technologies that it should include all these 23 data points, at least have it on the wish list, so to speak. Okay, so out of these 23 data points, we would say that 10 is crucial for recycling. You probably heard about this, but of course the fiber composition is super important. And a garment could be in several layers, or it could be, glued together in some way. So we need information about all the fiber composition in the garment. It's very important to have information about the textile finishing, because that could have an impact on recycling, some recycling technologies. Also, of course, the chemical content, but also recycling content. It is important to have information about when, for also looping a garment more than one time, that could be very important. Today, the current situation, it's only possible to sort automatically waste based on 3 data points. So the fabric color and the fiber composition we can do with the new technology, and we can also handle disruptors automatically. So then we have a gap. we probably need to go from handling 3 data points automatically that we can do today up to 10 to really do this automatically sorting based on data in a very efficient way. One data point is super critical, and that is to have a good way to define the condition level. Is the condition level perfect for a reuse market, or is it more suitable for recycling? And one insight with this is that this is something from the user phase, what happened to the garment during the lifetime. So it's not possible to include in an upcoming digital product passport. So we need other technologies like AI or to detect what is the condition of the garment if we want to include that in an automated sorting process. But we see this is very important, since that is the main data point when you have to take a decision. Should this go to reuse, repair, or recycling? So to have technology improvement on how to detect condition and also to define it in a a homogenic way in the industry is also important. So here we have an example. We have an active wear jacket and for sports. And here, well, this in the picture, it's very pretty, but we can imagine that is a worn out garment. So it's in a condition that is more suitable for recycling. Let's imagine that. And here are all the data points that is good to have if we want to channel it for fiber-to-fiber recycling. So we would like to know what is the outer layer, and we would like to know what's in the inner layer. We would like to know that it is hard parts and that it's designed for assembly, so it's easy to take apart. It's very important to have the treatments and what kind of treatments it is, and if its recycled contents is used. So as you see a little bit grayer, that is what technology can detect today, and the other data points, it's not possible to detect today. So if we would have all this data, we could easily channel it to a fiber-to-fiber solution. But that is for the future, okay? We will hope we will get there soon. Okay, so I will skip to the other part of this report where we explored scenarios. We explored what will the future textile ecosystem look like in 2035. So we built scenarios to understand what will the future look like. And we used the foresight method. So basically we worked in a method and a process together with a foresight method expert and with our partners to map different trends and aspects that influence development together, and then we identify the major uncertainties that will have an impact on the future. So we use the foresight method because when you think about the future, we have the EU textile strategy that gives us a vision of how we would like the future to become. But there are so many aspects and uncertainties that may impact the future in the different ways. So it's not interesting really, and it will not help us to think about one future. So in this method, we developed 4 different futures because we need to have an open mind and think about so many different possible developments to train our skills for planning for the future. So these scenarios are scenarios that are designed to ignite your curiosity and inspire questions about the future. It's not a description, a perfect description of what the future will be. It's rather 4 different futures where we have been successful in reaching the EU textile strategy in some aspects, but also failing in others. So it's about preparing and improving our skills to prepare for the unknown and a variety of different kind of challenges and possibilities that may occur. So these 4 scenarios can be used in future-proofing your plans, or perhaps, practicing these future skills. Are you prepared, basically, for the future? Because we are so much in the here and now, doing what we need to do in our everyday life. So what we did, we picked the 2, what we thought was the main uncertainties about the future. And that is, how will the markets develop? Will they be more global? Or will they be more local? And local, we mean more in Europe. Will the European value chains be improved? That we will circulate garments and materials more in Europe, so to speak, more recycling industry and so on in Europe. Or on the other axle here, will fashion continue to be so fast or even faster? You know, we are throwing away garments just after we bought them almost. Or will we slow down in our behaviors? Will we go for more prolonging the life? We will manage to, with an increase of the secondhand market and so on. So we thought these are the major uncertainties of the future. So from this, we developed 4 scenarios. So as I said earlier, these scenarios have both some success in achieving a sustainable circular value chain, but also failures, of course. And we also have a focus here, of course, on how is it with the European capacity and market and recycling and textile industry. Have we succeeded? Are we competitive and so on? And what about the consumer behavior? What happened with that? So I will not go into all of them right now, but I will give you an example, the scenario B. I hope that the sound will work now, because we have made some graphic movies from all these scenarios, and you can find them online. So let's hope and pray that we have sound on this one. I'm not a Zoom girl, so I don't know. We hope now that the sound works. No.
No.
You. Okay, thank you. Oh no, sorry. No, sorry. Okay, I will stop here. It's something, I don't know. Okay, but I am finished anyway. Okay, so you can find all the scenarios, and as you saw, there were questions in the end. So I think they are actually easy tool to use for design team, for your together with your team to see, can we future-proof our plans, long-term plans. Then you probably can have some more inspiration based on these scenarios. And in the report, you can also find the long version descriptions if you really want to dig deep into the future. Okay, thank you.
Thank you so much. It was really interesting, and sure, from the point of view of another research project, keeping into account future scenarios is of course useful, but especially I guess on the point of view of companies, it's even more important to have an idea of what's going to happen next. So thank you so much. It was really interesting also to see the points of contact, not in the presentation today, but in the one that we had in the last webinar. Also in tExtended, we have a big focus on data. So it was really interesting to see all the points of contact between the projects. And thank you again for the availability and the presentation on your results and work in SISUTAC.